Good morning, grade 8. Let's have science 8, right? But before anything else, let me check your attendance. We have Travis, Alred, Jairus, Lapis, Kamingawan, Kaizel, RJ, Ronilyn, Samantha Emma Rowell. One unit only. One computer only. 3 students from MIA.
We have a 2 laptop.
Okay. Storm, Travis. Okay, did I miss somebody? Right. Okay. For our science 8, let me share my screen. Okay, let's move to the next topic. Okay, hold on. Okay, can you see my shared screen now?
Yes.
Yes, sir.
For our next topic, it is lesson number 2, faults and earthquakes. Let's take a look at faults and earthquakes. Are you done with your report sheet?
Yes, sir.
That's great.
Yes. Yes, sir.
Okay, let me put it in full screen. Right. Faults and earthquakes. Let's take a look at the reason why we need to know the faults and earthquakes. Let's take a look at also the importance of this. Okay. What else? The causes of faults and these earthquakes, right? And how can we prepare ourselves for possible faults or possible effects of these faults and earthquakes, right? Are you still with me? Can you hear me?
Yes,
Yes.
sir.
Okay. A fault, this is a fracture or zone of fractures between two blocks of rocks. Okay? Faults allow the blocks to move in relative to each other. This movement may occur rapidly in the form of an earthquake. Okay? Or may occur slowly in the form of a creep. Okay? Faults may range in length in few millimeters to thousands of kilometers. It depends upon, right? Most faults produce repeated displacements over geologic time. During an earthquake, the rock on one side of the fault suddenly slips with respect to the other. Okay, the fault surface can be horizontal or vertical or some arbitrary angle in between. Let's take a look at this. Okay, there are different types of faults based on their movements. Two sides of a non-vertical fault are known as the hanging wall and the footwall. Please take note of the important terminologies given there, hanging wall and footwall. What's the hanging wall and footwall? Okay, hanging wall occurs above the fault plane and the footwall occurs below the fault plane or below it. Okay, again, hanging wall occurs above the fault plane and the footwall occurs below the fault plane. Get your notebook and write the important terminologies. Please take down notes. Okay, this terminology comes from mining. When working in a tabular ore body, the miner stood with the footwall under his feet and with the hanging wall above him. So this is now the terminology. So we actually came up with this terminology because again we extracted this from mining, okay, or miners. Okay, they usually use footwall and hanging wall in the process, right? Do you have any questions so far with hanging wall and footwall?
No, I already wrote it down.
All right. So as an illustration, this is your hanging wall. Look at the fault line. Okay, this is your hanging wall. This is the normal fault. Okay, and this is the reverse fault. So the hanging wall above the fault plane and below the fault plane, okay, this is your fault plane, is your footwall. Okay, let's move forward. Types of fault. Let's take a look at strike slip fault. What's with the strike slip fault? Okay, on the term itself, okay, strike slip fault involves the right as well as the left motion movement of Earth's crust. In a strike slip fault, the motion or movement occurs on near vertical plane when planes on either side of the fault move horizontally with respect to one another. If the movement is horizontal with respect to one another, it is called strike slip fault. Okay, these are the strike slip fault. We have lateral strike slip fault and a left lateral strike slip fault and right lateral strike slip fault. So the movement is what? What is the movement there? They are
Horizontal.
horizontal sliding past with each other. What is that all about? Deep slip fault. Okay, deep slip fault occur either on vertical or horizontal motion on movement of the Earth's crust. When you say deep slip fault, this is actually further classified into normal fault and reverse fault. The one that I am actually giving you a while ago, that those are deep slip fault. Okay, let's take a look at the normal and the reverse deep slip fault later. Okay, deep slip fault is developed at an angle to Earth's surface and relative movement of motion is up and down. If the movement is up and down, therefore it is considered as deep slip fault. Okay, you have two classification of deep slip fault: the normal fault and the reverse fault. Let's take a look at this one. This is a deep slip fault. Okay, the normal fault. Okay, this is your fault plane, correct? Okay, where is your footwall and where is your hanging wall? Okay, the normal fault is the footwall is above the hanging wall, so the hanging wall submerged on the process. Okay, the reverse fault is exactly the reverse or the opposite of the normal fault. Okay, the hanging wall is actually moving up and the footwall is moving down. Okay, normal fault. Okay, when upper rock hanging wall tries to move down, this is known as the normal fault. Okay, when crust is extended, the normal fault occurs. It is also called as extensional fault. Okay, the downward block between two normal faults dipping toward each other is called Graben. So let's take a look at this later. We have also a lot of examples here with the Graben and the Horst. The upward block between two normal faults, okay, dipping away from each other is called the Horsts. Okay, this is your foot wall and this is your hanging wall. Okay, reverse fault. When the fault is in opposite to the normal fault, it is called the reverse fault. So when can we say that this is a normal fault and this is the reverse fault? Okay, again, when upper rock or the hanging wall tries to move down, if it tries to move down, it is called the normal fault. Again, if the hanging wall, okay, moves down, it is the normal fault. Okay, but when the hanging wall tries to move up, it is called the reverse fault. Okay, how about this one? This is called the normal fault because the hanging wall moves down. Okay, on the other hand, if the hanging wall moves up, it is called the reverse fault. Okay, step fault. What's with the step fault? This is a fault system consisting of number of faults with parallel fault planes. Okay, the separated blocks slipping in the same direction along parallel planes, giving a step-like feature. This fault is also called fault terrace. Okay, just like this one. So we actually resembles what? A step-like
Looks like stairs.
looks like, yes, correct. It looks like a stairs. Okay. This feature, okay, came along with what? With a lot of disaster also. Okay. Throw fault. Okay, this is a fault system in which two normal faults occur whose fault planes are inclined, providing a common down throw side between them, and the block between two fault planes form a long trench called graben or rift valley. Some gravens are very long and also deep and may be filled with water and become water stream, just like this. Okay, so we have what? We have
Roof fault.
we have what? What can you observe there? What happened to the land surfaces there?
The middle sank.
Was it normal fault or reverse fault?
I think it's normal fault because it's just going down.
Mm-hmm. So what is this?
The hanging wall goes down while the reverse fault. The hanging wall
This
moves
is it.
up.
If the hanging wall goes down,
It's a normal fault.
it's a normal fault. Two normal faults. Okay. So this is the way rift valleys are actually created and some bodies of water. Okay. As you can observe, you can actually see horse and graven there. Okay. Horse is the upper part. Okay. While the submerged part, the lifted part is horse and the submerged part is graven. Right? Do you have
I'll
any
write it
questions so
down.
far? Question?
No questions about. Can I write it down?
Oblique slip fault. This is a combination. Okay, oblique slip fault has a component of deep slip fault and strike slip fault. Okay, generally all faults have component of both deep slip and strike slip. It is caused by a combination of shearing and tension of compressional forces, just like this. Okay, it is moving also horizontal and vertical direction. So shear tension and compressional forces. Okay, the movement of deep slip and what? Deep slip and the oblique slip fault is a combination of deep slip and
Reverse.
Strike slip.
Reverse.
strike slip. Strike slip meaning they are passing one to one another. Strike slip and deep slip. Up and down and left to right or right to left movement. Okay, strike slip and deep slip. Okay, it's a combination. Let's take a look at earthquakes. Do you have any questions so far with faults?
No.
No, not really. I can go back to the. I mean, after class, I can write
Question.
it down after class.
All right. Question. Why do you think is the reason we have faults?
Earthquakes.
Huh? Why do you think is the reason we have faults? What's with the faults?
So that the surface won't.
Hmm?
Ah.
Yes, Trav? Do you have any idea? Travis?
Wait.
How about RJ? Why do you think is the main reason why we have faults? Do you think is the reason? Cause of earthquake? It could be. Kamingawan?
Is it because of like the tectonic plates
Okay, why?
movement and it affects the
What do you
earth
think
and
is the
creates
reason? Why do we
earthquakes?
have plate tectonics? Why do we need to have these movements? Any idea? Grade 8?
No, sir.
We need to have this plate tectonics, the movements, okay? These tensional forces in order for us to what? To create. Changes of this will also create bodies of water, number one. Bodies of landforms. This is how your landforms are actually created. Okay, because of this
Oh, like
movements.
they separate.
Okay.
They
Number one.
separate. The islands separate in breaks.
Yes. Remember that. Remember your Pangaea? Could you still remember the Pangaea?
No, I
Yes.
can't.
Huh?
For me, no, I don't
Oh,
remember.
the continent of the ancient continent.
The ancient continent? You don't have an idea about Pangaea?
It's like a massive continent. It's like
Massive
every
continent? Huh?
It's like
Pangaea is an idea that all the continents are connected to each other, just like a jigsaw puzzle. That's Pangaea. Okay? So because of these forces, because of these plate tectonic activities, okay, volcanic activity, tensional forces, what else? Earthquakes, we created a lot
Tsunamis.
of landforms. We created also a mass body of water. Okay, seafloor spreading is still active until now because of this. Okay, just like your Pacific Ocean is still moving. Okay, still expanding until now. This is the main reason why. Okay, so we are what? We are reshaping Earth in the process. Okay, we need to reshape Earth in order to what? What is the purpose? Why do we need to reshape Earth? Why do we need to develop Earth? Okay, your lessons are interconnected, grade 8, right? So because we need to reshape Earth, okay, or we need to develop Earth simply because Earth belongs to what? To a Goldilocks zone, meaning to say that it can accommodate a lot of organisms, biological organisms, okay? To accommodate the need of these organisms, okay, Earth reshape itself, not in a natural way. This is the natural way of shaping Earth. That's the main reason behind, to accommodate living organisms. Right? Am I making this clear?
Yeah.
Okay. Again, your lessons are interconnected. You cannot separate science. It is connected to all sciences. Okay. Let's continue. Earthquakes. An earthquake is what happens when two blocks of earth suddenly slip past one another. Okay. The surface where they slip is called the fault or fault plane. Okay. The location below the Earth's surface where the earthquake starts is called the hypocenter or focus. Again, please take down notes. Hypocenter or focus. And the location directly above it on the surface of the Earth is called epicenter. Okay. Again, below where the word earthquake starts is the hypocenter or focus. And above on the surface of the Earth or crusts is called epicenter. I know that you heard already these terms, the epicenter, because it is usually broadcast on news that if there is an earthquake, we usually locate the epicenter of an earthquake. Okay, do you have any questions so far? Grade 8?
No.
Questions? All right.
So an earthquake is caused by rocks underground suddenly breaking and rapid
Yes, it is actually
movement
an
just
effect.
happens along the fault or whatever.
Correct. It is an
Okay.
effect of faulting. It is an effect of the movement of crusts or tectonic forces or tectonic activities, plate tectonics. As I said, these are interconnected. Okay, your lessons are interconnected. All you have to do is to take down notes. Okay. So in the illustration there, you can actually see the hypocenter. Okay, or the focus. Above the hypocenter is your epicenter. Simple concept. Okay, this is your fault plane. Do not make it complicated. Make it as is. Okay, sometimes an earthquake has foreshocks. Okay, the smaller earthquake that happened in the same place of the larger earthquake that follows. Or we usually call them aftershock. Okay, foreshocks or aftershocks. These are smaller earthquakes that happen in the same place as the larger earthquake that follows. Scientists can tell, they cannot tell, okay, that an earthquake is a foreshock until the larger earthquake happens. It should, okay, the aftershock should follow after the larger shock. Okay, otherwise you cannot identify it as an aftershock or a foreshock. Can you still hear me?
Yes,
Yes.
sir.
Am I lagging in your screen?
No.
Okay, let's continue. The largest, okay, main earthquake is called the main shock. Okay, please take note of the terminologies. Main shocks always have aftershocks that follow or foreshocks. Okay, these are smaller earthquakes that occur afterwards in the same place as the main shock. Depending on the size of the main shock, aftershocks can continue for weeks, months, or even years after the main shock. Okay, we are not dealing with a small piece of land here. We're dealing with plates, the plate tectonic. Okay, it depends upon also on the movement of molten rocks in the asthenosphere. Okay, so this is the main reason why we have earthquakes, because these plates move along with the asthenosphere. Okay, the molten rocks in the asthenosphere. Okay, pressure is built. Okay, the pressure is building up on the asthenosphere, and it needs to what? It needs to release itself. So the releasing of this will mean movements of the tectonic plates and also volcanic activities. Earthquake focus and epicenter. Let's take a look at this one. When you throw a pebble into a pan, waves move outward in all directions, correct? So when you throw a pebble on the pan or water, the waves move outward in all directions. In similar
Yeah.
manner, when rocks of Earth's crust break, okay, earthquakes occur and earthquake waves travel through the earth in all directions also. The same as when you throw a pebble on a pan. Okay, an earthquake is the shaking and trembling of earth that results from the sudden movement of part of the earth's crusts. Most often, earthquakes are caused by slippage along the fault in Earth's crusts. As simple as that. It slips. Okay, there is a slip or slippage of the Earth's crust. During the severe earthquake, the ground can rise and fall like waves in the ocean. Okay, the motion of the ground causes buildings, trees, and telephone poles to sway and fall. Sometimes loud noises can be heard coming from the earth. That is the why do we need to know about this first? What do you think is the main reason why do we need to know about this? Grade 8? Are you still with me?
Yeah, I am.
Sige, go. Why do you need to know? Let's have Travis.
Wait, can I think of an answer first?
Okay. How about RJ?
I'll think of my answer first.
You're still thinking of your answer. How about Kaizen?
I'll also still think about my answer.
Oh, you're all thinking about your answer. How about Samantha? Let's have Samantha. Samantha? Is Samantha around?
Yes, sir.
Okay. What do you think is the reason? Okay. Why do we need to know this first? Why do we need to know earthquake first? Samantha? Samantha,
Wait, sir.
you're still thinking of your answer? Okay. How about Kamingawan? Kines?
I'm also thinking.
I think I have an answer.
Go, Travis. The floor is yours.
Okay. Water dams are a thing, and if earthquakes happen, the dam will break, and buildings and other islands or whatever will drown into that probably,
Mhm.
which will make destruction, and just we might find a way to like lower those cases. I don't know. That's just my opinion.
Okay, you have a point. You have a point. Okay. Any other answer aside from Travis' answer?
We must educate ourselves about them so we can properly comprehend earthquakes and for safety also.
Correct. So both of you got the correct answer, Travis and RJ. Thank you very much. Okay. The main reason why do we need to know first these earthquakes is for us to prepare. Since these are unpredictable, we cannot predict this one. Just like when you have your typhoon, you can predict typhoon, of course, because it will just go inside the Philippine area of responsibility or PAR. But earthquakes, we cannot predict when an earthquake can happen, even until now. Okay? So, because this is unpredictable, we need to prepare ourselves. This is the reason why I am educating you. Okay? With regards to the possible effects of earthquakes. That's the reason behind. Okay? Our lessons here are not just for your grades. This is not just for the four corners of your classroom. This is a life skill. Okay? You'll be bringing this one all throughout. The most common cause of earthquake is number 1, faulting. Okay? As you have learned, a fault is a break of Earth's crust. During faulting, energy is released as rocks break and move. As they move, they cause nearby rocks to move also. The rocks continue to move this way until energy is used up or released. Okay? Same with your volcanism or volcanic activity. Right? It should be released. If there is a pressure building up, it should be released. Sure. Why is there pressure build up, okay, on Earth's asthenosphere? This is actually in the mantle. Okay. Well, definitely your mantle or your asthenosphere is still moving. Okay. It needs to move. Why? Because it actually creates electromagnetism or electromagnetic field on Earth's atmosphere. Okay. This is a protection for us. For what? Or any what? Any massive, okay? Any massive asteroids or any massive object that may come along in Earth's atmosphere or the solar radiation, for example. Okay? That's our protection, number 1. Number 2, why do we need this to keep moving? Simply because, again, our devices depends on this movement because this is electromagnetic waves. Okay, electromagnetism. Your compass is relying on this. What else? Our communication satellites also relies on this. That's how important it is. Okay. Earthquakes that occur on ocean floor cause giant waves called tsunamis or tsunamis. Okay. These waves can travel at a speed of 700 to 800 kilometers per hour. That's fast. As they approach the coast, tsunamis can be as high as 10 to 20 meters. See, the effect of tsunamis are devastating. Okay, they are one of the world's worst natural disaster that can hit a country. Would that be possible to happen here in the Philippines?
No,
Why?
So,
there's other countries covering us,
There's other countries covering us. Yes, you have a point.
and it's safe in Cebu because there's also there's 7,000 plus islands in the Philippines, so there's no way we're gonna get hit by one.
Correct. We have a lot of mountains also. Remember that these can happen if, again, we are surrounded by a lot of bodies of water, a big body of water. But we have a lot of mountains also here in the Philippines.
So it's kinda not really likely to happen, not even close.
Yes, correct. Let's move forward. You still have 2 minutes. Wait. Tsunami damage is first caused by the immersed force of the tidal wave hitting the shoreline. Tsunami, flooding, then continues to cause damage for several more weeks. That's how vast the damage can be. Okay. When an earthquake occurs, only part of the fault is involved in the rupture. The area is usually outlined by distribution of aftershock and sequence, or in the sequence. Some faults are deep inside the earth. Others are close to or at the earth's surface. Most faults occur between the surface and the depth of 74 kilometers. The point, this is the origin where the earthquake rupture and rocks break, is the focus again, or the hypocenter. We already discussed this one. Focus is the underground point of origin of earthquake, and the point of Earth's surface directly above the focus is called the epicenter. We already discussed this one. Okay. Earthquakes waves reach the epicenter first. This is where the most violent shaking of the ground occurs. Okay, to plot the Earth's location, earthquake location on the map, the epicenter must be located first. So if we gonna identify the epicenter, we can also identify how it spreads and how massive the destruction is. We have that's how we manage to have intensities. Okay. Earthquake waves are known as seismic or seismic waves. Okay. Seismic or seismic waves are waves of energy caused by the sudden breaking of rock within the earth or an explosion. Okay, they are the energy that travels to earth and is recorded by a seismograph or seismograph. Scientists learn much about earthquakes and the interior of Earth by studying the propagation of seismic or seismic waves. Seismic waves can be distinguished by a number of properties, including the speed of the wave travel, the direction of the wave move particles as they pass by, and where they do not propagate, or where does this wave stopped. Okay, that's how we identify these waves. Okay, there are a lot of different waves. There are 3 main types of waves or seismic waves. Okay, and they move in different ways, so that how can we classify them is based on how they move. Okay, these are P waves or primary waves, S wave or the secondary waves, okay, and the surface waves.